In this question, we are told that you may assume that the equation x cubed plus 7x squared minus 3 has a root alpha between 0 and 1. We're told then that the recurrence relation, xn plus 1 is equal to the square root of 3 over xn plus 7, with x0 equal to 1 can be used to find alpha. Find and record the values of x1, 2, 3 and 4, and then write down the value of x4 correct to 5 decimal places. Show that this is the value of alpha correct to 5 decimal places. So, initially starting off this question, just using a recurrence relation, so use your calculator to program this in. Start off with x0 equals 1, and then we can type this in on your calculator, replacing the xn with the answer button. If you do so, you should get that x1 is equal to. Now, since we're working to 5 decimal places in this question, I would usually put any working to at least 2 decimal places more than that. So we're going to work to 7 decimal places, which means I get an answer of 0.6123, 724. x2 is equal to 0.6277, 701. x3 is equal to 0.6271, 361. And x4 is equal to 0.6271, 622. Now alpha is equal to x4 correct to 5 decimal places. So let's just round our answer there to 5 decimal places. So we should have 0.62716. Okay, it's important you remember it says to give x4 to 4 decimal places. Now, the last part of the question asks us to show that this is the value of alpha correct to 5 decimal places. So if we take f of x is equal to the function x cubed plus 7x squared minus 3, as this is the equation we're trying to find the root of, what we want to do is we want to take the upper and lower bounds for 0.62716 rounded to 5 decimal places and do the change of sign test. So we're going to evaluate 0.627155 as the lower bound, and I'm going to evaluate f of 0.627165 as the upper bound that would round down to our root to 5 decimal places. Now, if I substitute into my calculator into the function 0.627155, I will get a value of minus 6.2 times 10 to the power of minus 5. Now, if there is a root line between this upper and lower bound, then I'm expecting my next answer to be positive. So when I substitute in 0.627165, I do get a positive answer, and I get 3.8 times 10 to the minus 5. So I have a negative solution, I have a positive solution. So it leaves me just to say, therefore, by a change of sign, test, what I know is that alpha must lie between 0.627155. Let's get that working. And alpha lies between and is below 0.627165. So alpha equals 0.62716 is correct to 5 decimal places. Okay then. So let's have a look and see how the marks are awarded on this question. Okay, so first mark is given for x1, assuming that at the very minimum 5 decimal places are given after the decimal point. There is then a standalone mark for getting that x4 is 0.62716 to 5 decimal places. There is a method mark for using the upper and lower bounds to substitute into f of x and to do our change of sign test. There is then an answer mark for getting a positive and negative solution, preferably listed like this, an actual value, when you've substituted in those upper and lower bounds. And then finally, there is an answer mark for a sentence explaining that you've used a change of sign test to show that alpha is 0.62716, correct to 5 decimal places. Okay, well, I hope you was able to understand my solution and that you followed how to mark it.